Let me show you another example on the power series method. So the question is like this. Solve y prime plus x squared y equal to 0. Okay, how to solve these questions? So first of all, you must know the y. So that is the first step. Okay, let me show you step by step. Step 1 is y. Y, you still remember? Do you still remember the formula? The summation m equal to 0 to infinity, and am x power of m equal to a0 plus a1x plus a2x squared plus a3x power of 3 plus a4x power of 4 plus a5x power of 5 plus a6x power of 6. So let me tell you, so this equation is fixed. Okay, so you need to remember this equation. So how to find y prime from the y? This means that y prime is, you differentiate the y to get the dy dx. Okay? So what will you get? That is the m from 0 to infinity. You differentiate the amx power of m, and you get m x power of minus 1. Okay? So the m is starting with 0. If m equal to 0, based on this formula, m x power m minus 1 will get 0. So you start with m equal to 1. So if you have m equal to 1, that one will be a1 plus 2a2x. Okay, 2a2 um, x power of 0 plus 3a3 x power of 2. This means that you every time you substitute the value of when m equal to 0, what will you get? M equal to 2, m equal to 1, you will get 1a, 1 x power of 1 minus 1, you will get 0. That is why you will get 2a2 x power of 0. Then when n equal to 3, so that will be 3a3 multiplied with x power of 3 minus 1, you will get a2, x2, x power of 2. So let's continue. When m equal to 4, so you have 4a4 x power of 3. Then m equal to 5, you have 5a5 x power of 4 plus 6a6 x power of 5, blah blah blah. Okay, it's continuously to infinity. Alright, so now you know the y and y prime. You can substitute in. You can substitute in the power series of y and y prime into the differential equation. That is y prime plus x squared y equal to 0. Alright, so let me write down after I substitute. Then equal to, okay, my equation, that one is here, plus x power of 2 y. So I move to the right hand side, that will become negative x squared y. So I substitute the y with a0 plus a1x plus a2x squared plus a3x power of 3 plus a4x power of 4 plus a5x power of 5, then plus a6x power of 6 plus, okay, dot dot dot. So this is, we finish step 1. Then we go to step 2. Step 2 is to expand the series and collect the same power of x. Okay, what does this mean? Okay, so you expand. This means that this one I will multiply in. Okay, so I expand it. So now I get a1 plus 2a2 x power of 1 plus. So this one is just the first part is just copy down. Okay, then equal to the part that I expand. Okay, here I get negative a0 x squared because I multiply in the negative x squared to the a0, I get negative a0 x squared. Then if I multiply in with the a1x, I get minus a1x power 3. Then I multiply in to a2 x squared, then I get negative a2 x power 4, and same to others. Okay, so I finished step number 2. Step number 3 is equating the coefficient of each power of x. Okay, what does it mean? Let's say I want to equating the coefficients of x power of 0. This means that I will compare. Okay, let me take a highlight. I will compare x power of 0, left hand side and right hand side. Okay, this one is x power 0, a1. But do I have x power of 0 at the right hand side? Don't have, right? If don't have, this means that it's 0. So it's a1 equal to 0. Then I continue with x power of 1. Okay, if x power of 1, okay, this one is x power of 1. Alright, what about right hand side? Also don't have. Okay, also don't have. Then I will just write 2a2. Okay, 2a2 is I get it from the value of x power of 1. Then right hand side don't have. So 0. So a2 is 0. Then I compare x power of 3. Okay, if I compare x power of 3, no, x power of 2, sorry, I haven't compared x power of 2. So let me compare x power of 2 first. X power of 2. Okay, I use the green color. X power of 2 is this one, the left hand side. Right hand side is this one. So left and right I got the value, therefore I can write down. Okay, left hand side I have 3. Left hand side I have 3a3, and right hand side I have negative a0. Okay, negative a0. So a3 equal to negative a0 divided by 3. Okay, that is my a3. Then I continue with x power of 3. Okay, I compare x power of 3. X power of 3 is this one and this one. Okay, so that I can write down x power of 3. Left hand side I have 4a4, and the right hand side I have negative a2. So a4, what is a2? a2 is 0, right? a2 is 0 based on the x power of 1. We found it before. We find it before, that is a2 equal to 0. So a4 equal to, okay, a2 also, right? So a2 is also 0. Now we keep compare. So we say a0, okay, x power of 4. X power of 4, okay, let me highlight. Okay, x power of 4, I have, okay, wait. I have x power of 4, this one also x power of 4. Okay, x power of 4, okay, a yellow highlighted, I have 5a5, at the left hand side, and the right hand side I have negative a2. Okay, negative a2. So negative a2 also equal to 0, therefore a5 also equal to 0. Then I want to find x power of 5. Okay. X power of 5, this one, and this one. Okay. Now, let's write down the x power of a5. So x power of a5, left hand side I got 6 a6, right hand side I got negative a3. So what is the value of a3? Okay, we finish up the a6 first. a6 is negative a3 divided by 6. Okay, this is also equivalent to a3. a3 is negative a0, right? Okay, a3 is negative a0 divided by 3. So negative a0 divided by 3. Then with initial one is negative 1 over 6. So I get a naught over 18. A naught over 18. That is my a6. Okay, so now we go for step number 4. Step number 4 is to write down the series solutions. So y, okay, I write down the y equal to a0 plus a1x plus a2x squared plus a3 x3 plus a4 x power 4 plus a5 x power of 5 plus a6 x power of 6 plus blah blah blah. Okay, so now I can substitute the value of a1, a2, a3, a4 until a6, which is I found it before. So a0 plus a1. Okay, if you look at a1, that is 0. Okay, this is 0. a1 you get 0 plus a2 also 0 plus a3 is negative a naught over 3, negative a naught over 3. Okay, plus a4 is 0, a4 is 0, yeah, a4 is 0 plus a5 also 0, and then plus a6 is a naught over 18 x power of 6. So I can simplify by taking out the a naught, then I get 1 minus, so let me cancel out those with 0. Okay, and then the others will be the remaining. 1 minus 1 over 3 x power of 3 plus 1 over 18 x power of 6. Okay, then minus plus something behind, so it's to infinity. Okay, that's all for this. That's all for this. That's all for this example. Okay, see you again.